All right. So our next speaker is Rediet Abebe. She is totally extraordinary. She's a junior fellow at the Harvard Society of Fellows and has been named one of MIT Tech Review's 35 Innovators Under 35. She's also been appointed or named to the Bloomberg 50 and received a Social Justice Award. She runs not one but two extraordinarily vibrant, or is co-running one of the two extraordinarily vibrant computer science, interdisciplinary research, and professional communities. One of them, Mechanism Design for Social Good, is about trying to take ideas from market and mechanism design and AI and bring them to social good applications across the world, and also making the community of mechanism design much more sort of open, inclusive, and engaged. And then Black in AI is about, we okay?
No, you're good.
All right, very good. And then Black in AI enables, empowers, networks, and connects different Black individuals in artificial intelligence across the world with order of like thousands of participants. This is all more impressive because she literally just finished her PhD. So she finished a PhD and master's degree at Cornell, and so she was a major player and founder of these organizations while a graduate student. In what is, I think, at least a first in the Econ CS community, or tied with first. She worked with other graduate students as well. And she has more degrees than I think any speaker we've had here before. So in addition to the 2 degrees from Cornell, she also has a master's in applied math from Harvard, a master of advanced studies in mathematics from Cambridge, and a bachelor's in math from Harvard, where, on a personal note, I should say, I first met her as a student here over a decade ago, when we were both pursuing, math degrees. And I remember thinking at the time, so she took over the Harvard College Mathematics Review, our undergraduate expository journal that I co-founded. And I remember at the time thinking she was one of the most impressive students I had ever met. I think, here's somebody to keep watch for. And as I was getting older and watching her progress, I was, updating my prior even more and more positively, right? So I, high baseline and constantly positive upward updates. And I'm thinking gosh, I've got to have her at one of my conferences. But really I'm repaying a favor because she ended up organizing big conferences at sort of light speed. And I had the honor of speaking at the first Mechanism Design for Social Good workshop. So I was her invitee, long before she was mine. So I'm doubly honored to finally be able to repay the favor and host one of the most extraordinary students I know, and now one of the most extraordinary colleagues I have. Please welcome Rediet.
All right. Can you all hear me? Yeah? Good. Okay. So good. It's really good to see you all. I've heard about the morning talks, so I'm very excited to be following them and to be talking about some very powerful applications of data-driven work that I've had the fortune of being able to do, but I actually think is going to be very generative and might even you might even be able to come up with some ideas of your own, or we might be able to discuss some ideas. So very happy to share this with you all. So this is work that I started when I was an intern at Microsoft Research in the New York City lab. So this happened about 2 summers ago. And at the time, I was specifically interested in kind of using text-based data to understand socioeconomic inequalities. And in particular, we ended up being interested in public health applications. So we wanted to use text-based data to illuminate issues that are ill understood, that are not as well understood related to public health. And at the time, I was at Microsoft Research, so one data that we had access to was search data, right? So we thought we have access to this very rich data source from across the world, and maybe it contains some information here that might be useful. And since starting that work, that has informed a lot of the work that I've wanted to do going forward, and I'll be able to talk to you a little bit more about the broader ideas here later. But we'll start with this one particular project, and it's joint work with my then mentors Chandra Hill and Jen Wortman-Vaughan at Microsoft Research, and Peter Small, who is currently at the Rockefeller Foundation, but is someone who's worked for the Gates Foundation for several decades, and then Andy Schwartz, who is a computer science researcher and professor at Stony Brook University. So let's get started. So If it lets us get started, let's get started. All right, so here is, all right, here we go. So, so we know that data-driven policies are embedded in various health contexts, and they're fueled by the availability of very high-quality, comprehensive data that we can get sort of at the tip of our fingers, right? So, for instance, in the US, if you go visit the doctors, you kind of see something that looks like this, maybe not quite this, but something that looks like this, where there's just data being collected left and right for a variety of different uses. And this data is used to supplement, upgrade the design and evaluation of health policy across the United States. So the data that we collect in hospitals, clinics, and various health facilities are very useful in trying to make decisions about, say, how we want to allocate different funding resources, where we should focus, what emerging concerns there might be, and all these things, right? And it's not just hospitals and clinics. It's also even everyday devices like Fitbits or your use of social media data. And all these things are all fueling this design and upgrade of health policy that I've mentioned. But that is, and that's used for a variety of different cases, including, sort of targeting different populations that might have been underserved for making decisions about funding allocations and so on and so forth. But that reality does not cover everyone, right? So for instance, if you're thinking about maternal experiences in the United States, if you're thinking about Black and Latina mothers especially, we know that we have very little data about their experiences. We know there are issues, right? Because we know that there's high rates of maternal mortality for all women in the United States, and especially those who are Black and Latina are experiencing it at even higher rates, and we don't really have a good idea why this might be happening, right? And part of that issue is that we just don't have a lot of very good quality data that we can use to kind of get at this issue. Similarly, it's known that autism is underdiagnosed among Hispanic children, and part of the reason is that we just don't have enough data on Hispanic populations, especially if you're focusing on immigrants and undocumented immigrants especially. They're just not in our data sets. Likewise, there are entire communities, like the trans community, that are just entirely missing. It's not even some individuals, it's the entire community that's entirely missing. So it's only in 2016, I believe, that there was a large data set collected specifically on the experiences of trans individuals, right? So we have this, huge contrast. On the one hand, we have this deluge of data from all these different resources that we can use to upgrade different policies and really target information as needed. But on the other hand, we have entire communities that are just missing in our data sets, whether they're supposed to be comprehensive or focused on the specific experiences of individuals. And a very striking example of this is thinking about developing nations, right? So I was born and raised in Addis Ababa, Ethiopia, and these images that you see of like someone walking around with like a clipboard, manually jotting down people's answers and trying to get at information in that way, or this picture that you see on the left-hand side where you have a hospital that has like these rows of beds and kind of that are in underserved facilities. This is not very far from the reality, even in present day, in many developing nations, and I was focused on African nations, so many African nations. So that's a huge issue, right? And this is an issue that's very well known. A lot of organizations like the WHO and the African Union have long said, we just don't have enough data, so we don't actually have a good measure of different issues, and we're not able to identify sort of emerging issues. And so, and it's especially a problem because if you have limited resources, which is the context that you're in developing nations, that you need to target and identify problems and sort of use your limited resources in an efficient manner, but that's harder to do, right, if you don't even have kind of basic information like, say, disease prevalence rates. So how have people tried to go around this, especially folks working in global health and public health? Well, there's sort of these top-down approaches, right, where you try to use, say, census data or some other data that's like collected by the government or other organizations, and you try to get at what you can using that maybe more coarse data set. And there's also sort of like these bottom-up approaches where the picture that you saw, right, where someone's going into villages and kind of jotting down people's different experiences, that's kind of used to surface some information as well, right? So you just have this top-down approach and this bottom-up approach. Both of them have limitations, right? The top-down approach doesn't give you maybe a lot of fine-grained information, and the bottom-up approach is wonderful, but it's not very scalable, right? So here's an opportunity for someone with my kind of training to kind of supplement this already existing work. So this was sort of where we started when we wanted to think about this project. And specifically, we wanted to focus on HIV and AIDS because we wanted to work on the African continent. HIV/AIDS is still sort of the disease that has the highest burden across the continent. And specifically, we thought about not trying to get at information like prevalence rates or mortality rates, but thinking about information, right? Because people come online because they're trying to seek some sort of information, and we have that data. Search data includes all these things that people are asking. And we know that information is very key for disease management, especially for HIV/AIDS, because we know that it affects transmission rates, right? People knowing how the disease gets transmitted and also how it doesn't get transmitted really impacts the disease sort of prevalence and also kind of knowledge across the continent, across communities. We know that for individuals that are HIV infected, having valuable information can help with managing the disease. And we also know that testing, especially, and having information about where you can get tested, why you should get tested, can also be very valuable in kind of limiting the spread of the disease and managing individuals that are HIV infected. So what we wanted to do is then focus on people's health information needs specifically using this data source that we had. And we wanted to use that to target education and programming efforts, right? By identifying maybe some information that should be out there that's not out there, maybe some misinformation that might be out there. We can use that to target education and programming efforts. So why do we want to use search data? Well, it's all the obvious stuff that you would think of, right? So internet penetration is growing very rapidly across the continent. There's been a growth of about 31% over the past since 2016, right? That's a very big deal. That's a lot of individuals that were not previously online, that were not really even previously in any data sets that you might want, that are now coming online for the first time, right? So it has, you have this ability to kind of identify and understand the experiences of those individuals. Search data is scalable, real time, it's relatively cheap if you're at one of these companies, and that's been demonstrated with a bunch of other diseases and a bunch of different contexts, right? Like, you might know of the flu, Google flu trends, but it's been used for like norovirus, all sorts of diseases across the world. And we also thought that especially it can be valuable in kind of supplementing these bottom-up surveys that I mentioned to you, right? Rather than sort of going in and relying on individual surveys that you might conduct, maybe you can have also this data source supplementing that to kind of make it more scalable and maybe surface issues that have not been studied before. But there's obvious ethical considerations and limitations of the data. I'll mention two here, and then we'll talk about more of them later, and also we can talk offline. So, before even accessing this data, I had to go through like a ton of training, and we also used a lot of scrubbers to make sure that we didn't use personally identifying information. But that's not enough, right? These are like, if you look at search data, it contains people's like everyday anxieties and concerns. So even if it's anonymized, it contains people's like real day-to-day experiences. So you have to approach it with sensitivity to that. And then also, it's not supposed to be a replacement for existing methods, right? It's known that search data has its own limitations, and you should not be in a situation where you're now relying on search data, really any other data source that may be web-based to say, I don't know, predict HIV prevalence rates and then use that as your sole source of information, right? So these are kind of huge caveats going forward. But using, keeping those in mind, we wanted to see whether it can still shed light on people's health information needs related to HIV and AIDS. And we studied all 54 nations in Africa. So we studied all the nations. And we also wanted to ask, people are coming online to ask these questions. How are those needs being met online, right? So it's kind of a two-part question. We'll talk about the first one first. And so the way that we collected the data is we looked at all searches from an 18-month period from January 2016 to June 2017, and we looked at all searches that had the words HIV and AIDS. That's just how we filter the data. And this data contained, people's raw queries. It contained the country where the queries were issued. It sometimes contained the city, but not always. It contained the date, and it also contained traffic count, right? So it can say something like, what are HIV/AIDS symptoms on, February 2nd, 2016 from Ethiopia, right? So it could be something like that. And I should say also, if you have any questions or thoughts, like jump in the middle. I'm happy to answer them as we keep going rather than waiting until the end. So okay, so we have this data, right? We did the first pass thing that we could think of, which was if you have a percentage of searches that contain the words HIV or AIDS in the continent, right, and you map them like you have in this heat map, you see some patterns, right? You see sort of the countries in the southern part of the continent are showing higher fractions of searches containing the words HIV and AIDS, and those in the northern part not so much, right? And we thought, okay, what if you were to map this against, say, HIV prevalence rates, right? So on the right-hand side, you have adult HIV prevalence rate in each country, and on the left-hand side, you have the fraction of searches containing the words HIV and AIDS, and we saw that this has a very high correlation rate of 0.7, it's a Spearman correlation rate. And we did this just as sort of like just a first pass, like just we wanted to see whether the online experiences of people might be mapping to the offline experiences of the countries in which these searches were issued, right? So we think that there's some association. So we think that this data might be actually containing some information, and we can use that. But what we were really interested in was digging into the searches themselves, right? We wanted to see what information people were seeking. And for that, we used like topic modeling methods. Specifically, we used LDA, latent Dirichlet allocations, which is sort of a method. So LDA basically treats a set of documents that you might have. Here, our documents are individual search queries, so they're very short, right? So it takes as input these documents, and then as output, it gives you sort of a cluster of words that you can effectively think of as topics, right? They're sort of semantically linked words. So basically what it's doing is it's treating your documents as a distribution of topics, right? Let's say that I had a search that said, what are HIV AIDS symptoms and how can I manage it? This could be like, related to like a topic related to symptoms, and it can be related to a topic related to disease management, right? So it treats your documents as a distribution of topics, and it treats topics as sort of a distribution of words, right? So it gives you basically as an output a cluster of words that you might associate with a given topic. And the number of topics is a free parameter. You get to set how many topics you want out of it. We ended up setting 100 topics, and that was because we tried it with different topics, and we saw that the 100 topics were most interpretable. When we had more topics, the topics kind of got very divided, and it was not quite as useful. And when we had fewer topics, they were sort of very coarse and generic and not as useful. And the way that we did this was actually, we printed out the topics and we gave it to health experts, and we said, which sets of topics seem useful to you, right? Because it was very useful. It was very important to us that the output of our study was going to be useful to people working on the ground, people working in public health, and so on, right? So if you're working in like natural language processing, I'm happy to have this conversation with you. I have a lot of thoughts, but if you're not, then ignore what I'm saying. So good. So I'm going to show you a sample of 6 topics. They're, you might think they're cherry-picked. They're a little bit cherry-picked, but actually a lot of the other topics are also very interesting. I'm happy to tell you about them later. So the topics were very, it spanned a full range. So there were topics that we expected, right? So we had topics like, the symptoms topic had words like pain, sign, lymph, swollen node, so on, right? We expected to see topics related to symptoms. There was one related to drugs and medication, again, to be expected. It had words like drug, treatment, antiretroviral, alcohol, and so on. And there was a topic related to breastfeeding, another one related to pregnancy also, again, to be expected, right? We know that a lot of people come online and ask questions like, I'm HIV positive. If I breastfeed, will that transmit the disease to my infant? And other questions related to pregnancy and breastfeeding. So I should add also the numbers that you see there measure the frequency of the topic within the entire data set, right? So you have 100 topics, the average would be 1. So some topics like symptoms were more prevalent, and other topics, let's say, drugs were relatively less prevalent, right? So that's what the number indicates. But there were some other topics also that we didn't expect, right? So there was one related to stigma and discrimination that had words like, workplace, ethical, legal, relations, stigma, issues, discrimination. So these were individuals basically asking questions like, I'm HIV positive, can my boss fire me? What are some sort of legal protections that I have? And this is a huge issue in a lot of nations in the continent, really here also in the US. And there was another one related to natural cures. This was like, for me, the most fascinating topic, right? I was just like, this is magic, how does it work? Because it had, searches like, cure black seed herbs, moringa, right? So these are like plants and herbs, right? So people asking, does garlic cure HIV? But it also had words like, prayer, prophet, people, testimonies and so on, right? So these were also searches related to like, prophet XYZ cured HIV and stuff like that, right? So somehow the topic knew that these were related, and they are. And I thought this was amazing. And then there was also more nuanced topics like gender inequality, right? So there were people asking things like, how does gender inequality or how does relationship inequality or marriage inequality impact HIV prevalence rates, right? So there were some very nuanced issues here that were also emerging as well. So I'm just showing you a cluster of words, right? But actually, this is a much more kind of usable set of outputs because you can look at representative queries, right? So the natural cures topic, you can see, what are some sort of representative questions associated with that. So it has things like prophet, whomever heals AIDS, and HIV healing prayers, name blanked out, olive oil extract cures HIV, and so on. I blanked out the names just because we blanked out any personally identifying information, but I've given this talk to like a group of students in Nigeria, and they knew everyone there because so they were like, oh, we know that guy, and I was like, well, okay, I'm still not going to include his name, but like, I'm glad you know, right? So it was kind of interesting to me because when I saw it, I was like, oh my God, right? And like when I present to a room that looks more like this, people are like, oh, that's really interesting. But then in other contexts, people are like, oh no, we know who that person is. Like he has like a YouTube channel, right? So it's really interesting what's like new information for some communities and what's like not at all new information for others. But so we have these representative queries, really great, right? Because, think about like the surveys that we talked about earlier. People know that like, garlic cures HIV is a belief that exists out there. People know that, and so you can have surveys related to that. But, what if you have like this belief that lemon baking soda cures AIDS being very prevalent, and you can see that in our data set. You can see how prevalent that belief is in our data set, but it's not yet kind of known out there, right? And so if you don't know what questions to ask, then you're not going to ask them, right? So here's an opportunity for us to actually surface maybe emerging beliefs, or maybe beliefs that were out there but just not discussed, right, because of stigma or any other set of considerations. So we have this opportunity to kind of shed light on those issues. So that's been kind of one immediate application that's been really helpful. So, okay, so I showed you a bunch of topics, right? And you're like, great, what can I do with them? Well, you can look at prevalence of those topics, topic popularity by country. You can also look at topic popularity by gender, by age. I'm only going to show you the country in the interest of time, but you can look at all sorts of different associations. And in particular, we asked, are topics associated with disease prevalence, right? Do they show any associations with disease prevalence? We'll focus on just one topic. We'll focus on the stigma and discrimination topic that we saw earlier. And so we ask, in countries where the stigma topic is relatively more popular, do you expect to see higher or lower rates of HIV, right? And so we're actually going to play a game. Who thinks that in countries where there's higher rates of searches related to stigma, who thinks that in those countries HIV prevalence rate is higher? Okay, and who thinks that it's lower? Okay, so I think it's like more higher than lower, but not by much, right? So as it turns out, it's higher. And I should say that I also thought about this before we ran this analysis, and I convinced myself that I think it's also going to be higher, but I got the reasons wrong. I got the causality wrong, because what I thought was that if you're in a country where something is more prevalent, then you have like a better model for it, right? And so you might have like different ways of like stigmatizing against it. Whereas if something is super rare, then you just might not even think about it enough to stigmatize against it. That was sort of like how I thought about why this association might exist. But what was kind of cool was that we went on and we read a bunch of health papers to try to understand why this positive association might exist. And there was this belief that that we think that it's going to be positive, but the causality is in the other direction, right? Where because something is stigmatized, and especially HIV, if HIV is stigmatized or highly stigmatized in a country, then people are less likely to get tested. They're less likely to adhere to drugs. There's more likely to be less useful information out there because people don't talk about it as openly as one would for something that's less stigmatized. So that drives higher transmission rates. That drives sort of like less good management of the disease, and so on and so forth, right? And it was really cool because this was something that people working in public health had expected. They've talked about. They'd even shown in sort of smaller contexts. And here it is in our large data set, right, where on the x-axis you have the HIV prevalence rates, and then the y-axis you have the relative topic popularity, and you see, actually, we saw like a statistically significant association with the stigma topic and HIV prevalence rates. And what was even more remarkable, I mean, this is to be taken with a grain of salt, but it's still pretty cool, was that these countries that you see as sort of being outliers, if you search on, if you search and try to learn more about those countries, you actually find that there is reason to believe why these countries would be more of an outlier. So if you look at, say, Botswana, that has, about the same HIV prevalence rate as Lesotho. It's about 20% for individuals between ages 18 to 48, I think. It has a much higher, topic popularity for the stigma topic. And when we dug around and we learned about both of these countries, what we found was that Botswana is a country that struggled a lot with HIV stigma. They'd experimented and maybe even implemented some policies where people could fire you for being HIV positive. There was even consideration of mandatory HIV testing and so on, right? And so the disease is very highly stigmatized. But in countries like, say, South Africa that have been working on destigmatizing the disease as part of their health campaign efforts, you see that sort of the stigma topic is slightly lower than other countries that have comparable HIV prevalence rates, right? So it was kind of cool to see this. It was very cool to see that the positive association between the disease prevalence and popularity of stigma. Yes, question in the back? Yeah, so it's very hard to do causal studies with observational data, right? So I hesitate to say anything about that, but there is evidence from public health, right? People have reasons to believe why the causal direction might go in that way. But I think there's like some cool studies to do potentially, maybe using like a time when if a specific campaign was launched, then maybe you could look at the data before and after and try to understand. Yeah. Good question, though. So, okay, so we're gonna, I have until 11:30, right? All right, so I have about 10 minutes. What's that? All right, good, okay, so we have time. So, great, so we talked about the topics, but this is just like, us looking at what people are putting into these search queries and then trying to gain some information from them, right? But what are we showing them in return? Well, I was doing this study, behind my computer screen in New York City, so I was limited in trying to understand, what information people were getting offline because I wasn't located in the African continent at the time. But we could look at what we were showing them online, right? People are showing up, they're searching for whatever on Bing because we were using Bing, and then they were seeing some set of web pages, and we could even see what they clicked on. We could see how long they spent on what they clicked on, and so on and so forth. And so we wanted to understand, does user behavior change by topic with which their queries are associated, and also even more importantly, is the quality of content that they're seeing affected by the topic with which their searches are associated. I'm only going to show you the quality of content results, but happy to talk about the behavior stuff offline too. So what we did was we looked at a sample of web pages that people would see, right? So we looked at, we picked 6 topics that we liked. We picked, sample search queries from like the most representative queries from those. Then we looked at a sample of web pages that they would see when they searched for that, right? And then we took the content of those web pages and we had them evaluated by folks with at least graduate level training in medicine and public health, and we asked them, look through this webpage and see whether there are any issues or serious issues with relevance, accuracy, and objectiveness in health, right? So they were not judging the usability of the website or design or anything. They're just looking at the content and saying, I'm a doctor working on tuberculosis. We looked at 3 diseases. We looked at HIV, tuberculosis, and malaria. So we had people who had experience with all three of the diseases. So they looked at the content and they said, I see these issues that are kind of maybe not serious, somewhat serious, and very serious, right? So these were evaluated by folks with better health experience than I do, right? I have none. So those were evaluated, and what we found was that these 6 topics that we picked out as being kind of maybe some of the more interesting ones showed significant variance. So this was rated on a scale of 1 to 5, where 1 means that you have very serious issues with all 3 of those metrics that you see there, and then 5 means that there are no serious issues with relevance, accuracy, or objectiveness from a health expert's perspective. So topics like stigma and breastfeeding and drugs had very high ratings. It was like 4 and up for all 3 of them, right? That's kind of reassuring to see. The average was like I think 3.3 or something like that. It was between 3 and 3.5. And epidemiology was just under, but it's not statistically significant, right? And then we had the natural cures topic, right? The topic that I showed you the representative searches for, that has a rating of, I think it was about 1.5 out of 5, right? So more times than not, it showed very serious issues with relevance, accuracy, and objectiveness, and so there's potential for sort of health misinformation here. Why do we think, well, actually, before we talk about why we think that's happening, actually, what does that even look like, right? So this is a snapshot from me. I just searched this myself, right? And I looked at like one of the searches that I saw, which was, does garlic cure HIV? Very common search. And when you search for it, it might even happen now if you wanted to try this. And also it happens on Google and Bing. This is not a Bing issue. It's just like, I think, search engines in general. So when you search for this, you see that the top webpage, and it's not even like the top webpage, it's a highlighted webpage, is a website called miracleofgarlic.com, right? And I looked through this and I thought, I don't think I agree with a lot of what's being said. And in fact, people who rated our websites, the sample of websites that we showed them, also rated this website to be very low, right? So it's a website that they felt had serious issues with relevance, accuracy, and objectiveness. And you might think, okay, well, should we really be intervening here anyway, right? Like, were we to actually fudge around with any of the results? But actually, we do that, right? Because if you're searching for antiretroviral therapy HIV, then the results look very different. You have a website that was consistently rated highly by folks who rated our websites. On the left-hand side, you see a Wikipedia page highlighted. And then what's even cooler, I thought, was that it has like these sort of similar searches recommended. It says like, what do you want to know about the condition? And it tells you like different searches that you could click on, right? So, you're searching for antiretroviral therapy, but you could also ask like a table of antiretroviral drug interactions, right? So it suggests that for you. These 2 experiences look very different, right? And so user behavior is different. The quality of content that they're seeing is different, right? So this is one opportunity here for us to think about, what our role is in what information people get online. And we talked about the issue of potential health misinformation in this context. And we might ask, what are the different sources? Well, one obvious source is just the topic of queries. We're not going to go and say, hey, I see you're about to search for something related to breastfeeding, but actually I would prefer that you search for something related to antiretroviral therapy. We can't do that, right? People are going to search what they're going to search. So that's one potential source where we have less leverage. But there's a couple of places where we do think that actually it's impacting the results and where we do have leverage. So one is the search engines themselves. We looked into them a little bit. We looked at Bing, like the back-end processing that Bing does, right? So if you search for something and it has a typo, then Bing might actually correct that typo so that it can map your searches to better quality results. And we found that that kind of back-end processing was being done less for searches related to natural cures and remedies. So if you misspelled, does garlic cure HIV, but you misspelled garlic with a K, it's less likely to fix that than if you misspelled, let's say antiretroviral drugs, HIV, right? So that's one potential place where, there's a potential intervention here that might be useful. Another place is actually the web pages themselves. So we looked at high authority websites like CDC, UN AIDS, NIH, you name it. And we looked at how many web pages they even have available for us to map, right? Imagine that Bing was performing as well as you would like it to perform, right? But at the end of the day, it can't create web pages that don't exist. And what we found was that for a lot of searches related to natural cures and remedies, there were actually very few web pages, if any, that could be retrieved from high authority websites. So this is something that we're in conversation with folks at the NIH about, right, to have web pages relevant to some of these topics that we think, where we think there's not enough high quality content out there, just so that it can be an option in the results page that people might see, but it's kind of a cyclic thing, right? So it's going to be sort of an ongoing effort. So I'm going to try to kind of wrap up here. I've mentioned to you that we're working with the NIH. I'm actually serving on the advisory committee to directors working group on AI. I've been doing it for the past, since January 2019. It's an ongoing effort. We've presented our interim results to the ACD, which reports to the general director, and we're going to present our final results. So it's a broader effort. We're thinking about all the different ways in which AI can be useful in public health contexts. And so if you have ideas, please come find me, because there's room for us to suggest more things. I want to hear what you think could be done to kind of create better bridges between the AI community and the public health community. And more broadly, also, Scott mentioned the Mechanism Design for Social Good community. It's a group that is focused on uses of mechanism market design, but also algorithms and optimization to help improve access to opportunity for disadvantaged communities. So it's been going on for the past 3 years. It's a vibrant community. It's grown significantly. I would love to talk to all of you about it. There's many ways to get involved. We have people working in government organizations. We have people working in NGOs. We have researchers from sociology, computer science, economics, you name it. It's a very vibrant community, one that I'm very passionate about. And if you want to talk about it, I'm very happy to set aside more time later today or even some other time. So I'll just stop there. And I'll say that if you go on our website, there's a way to sign up for our email list and different ways to get involved. So please do so. And thank you.
Awesome. Let's thank Rediet.
Hi, I enjoyed your presentation a lot. And I have 2 questions. So the first one is, I noticed that for the topic extraction, you use the LGA algorithm.
That's right.
And then for each summarize each clustered topic, you have kind of keywords to summarize the meaning of this cluster, like breastfeeding or natural cure.
Yeah.
For that keywords, is that your completely your subjective summary, or is there any algorithm to
That's a very, very good question. So usually what happens is that people just look at the topic, right? They just look at this cluster of words, which is an output of the algorithm, and then they say, well, that looks like symptoms to me, so I'm just going to call it symptoms, right? And so you do it manually. What we did was we actually gave it to a health expert, in particular Peter Small, and we asked him, because many of this was actually fairly straightforward. I was like, this looks like symptoms, and he's like, yep, that looks like symptoms. But there were some others, for the TB data set, where I was like, this looks like drugs, and he was like, actually, this is specifically about multi-drug resistant TB, right? So he was able to identify more specific topics that were better descriptors. So it was actually done by someone else who has more health training than I do, which is none. I have none.
Yeah. Okay, thank you. And another question. Yeah. So how do you decide what is the more optimal number of topics to be extracted? It could be 50 or 100.
Yeah.
What's an optimal number?
Yeah, also a good question. So we tried out a bunch. So we tried 10, 20, 50, 100, 200, 500, 1,000, maybe more. And we looked at the output. And usually what happens is basically that if you have something that's a smaller number, then a lot of things get collapsed and they're not quite as usable. And then if you have a very large topic, then you would have the symptoms topic replicated many times, but it actually looks the same and it's less usable. So again, we just relied on our public health expert in our.
There's no actual numerical or metric.
No, no.
Okay, and a final question, sorry.
Yeah.
And for your result, you want to see how the research content is relevant or accuracy to the related topic. And from what I heard is it's again based on the medical experts knowledge as a subjective analysis. Is there any way in the industry there's kind of algorithm based relevancy with the topic?
Yeah, so we actually, I mean, I would say that it's not subjective, right? I think someone who has medical training looking at content and measuring how accurate it is from their expertise is actually not a subjective process. So, so for us, that was actually much more comfortable. I'm not aware of any algorithms that might be able to measure how accurate something is. Even if they existed, I would not feel so confident using them because of this issue that I showed you, right? Where there's like issues of bias, right? Because if something is not searched enough, then the algorithm is just not familiar with it, right? And so there might be issues of algorithmic bias there. So I think even if such an algorithm existed, I would have maybe had it as like a secondary thing to compare, right? I think I would have still wanted to have someone who has health expertise to measure what's going on here.
Yeah, because the search result that the website presents is already based on NLP algorithm.
Exactly.
But it's already algorithm biased. So
Yeah, exactly. Yeah, but really awesome set of questions. Thank you. Yeah.
Thank you. Further questions? Let's maybe go up and then work our way back down.
I have a related question on the subtopic mining. How did you get those related queries? Are they from LDA or subquery?
Yeah, so also a good question. So I mentioned in passing that each word basically has like a measure of how associated it is with the topics, right? You have like the probability of topic given word. So we used, I mean, those are the weights that we used to like, that was like cure was the most associated, and then oil was the second most associated, and so on, right? And then what we did was we basically averaged them, right? So we looked at the probability of topic given word for chlorine and for dioxide and for cures, not HIV because HIV existed in almost all of the searches. And then we just looked at the average for each of the queries, and then you can just rank the queries by that. And that worked fine, actually. It worked pretty well, yeah.
Sorry, let me clarify a bit. So do they depend upon co-occurrence with HIV?
Basically, okay, so HIV or AIDS is included in all of our queries, right? So in that sense, co-occurrence with HIV is actually not the most informative thing. But what LDA does is it's looking at like co-occurrence of topics, right? So co-occurrence of words in these documents. And so you would be looking at like chlorine and dioxide, and then chlorine and cures, and chlorine and HIV, I guess, and so on. So so that's already sort of embedded in the algorithm in the process, yeah.
Yeah, thank you.
One more question over here.
I have a question about the limitation of language. So,
Oh, awesome question. Yep.
So you already did some study about how the fact that some of these countries don't have the main language is English to
Yep.
limitation and the topic choice.
Yeah, so that's such an awesome, I think it's an awesome consideration. So we were worried about that too, that we felt like, maybe there are a lot of searches in Arabic, French, Portuguese, and maybe also some other languages. And so what I did was I spent a fun 3 days sampling a bunch of random searches and like looking through them manually and seeing which ones are definitely in English and which ones are definitely not in English and which ones I couldn't decide, right? And what we found was that it's in the appendix of the paper, so you can get the exact numbers, but something like 95% of all searches were in English. And then further, a lot of the searches that were not in English were concentrated in like 3 countries, I think Egypt, Senegal, and a third one that I'm forgetting, but it's in the paper. So because of that, it didn't actually affect our results. And I think it's because I don't really speak French. I speak a little bit of French, and I've noticed that it's not very, search engines are not very usable in other languages right now. So I think people are sort of forced to use English if they speak English at all. I do think that as search engines become better in other languages, or as more people come online that don't speak English in the continent, then coming up with like a multilingual approach here will be absolutely necessary. But so far it's not quite necessary. But yeah, but very good consideration, I think, yeah.
So cool. All right, let's thank Rediet again.